Okay, good morning, everybody. So let me just make a very quick introduction. I hope you can all hear me. I see there are 24 participants so far. So we are expecting maybe somebody else will join during the next few minutes. So let me just share my screen to show you one slide, just to recap where we are and what we're doing. Okay, I guess you can all see my screen. Okay, so last week we started this cycle of virtual trainings, and we focused on the use of a software which is called HEC DSS View, which is meant to manage hydrological data, store hydrological data according to a standard. And so this was our first step that we meant to achieve with this group of trainings, considering all the tools that we are working with, that you can see in this slide that I'm now sharing with you, that you should be familiar with. As you remember, in this project, we are working on several so-called working packages. First one is for hydrological and hydraulic model, work package 1. Work package 2 is for water resources planning models. Work package 3 is on sediment management. Work package 4 is on Nile toolkits. And then work package 5 and 6 more on the IT infrastructure and on the platform that we are going to develop to share model results and maps. Since mapping is one of the cross-cutting topics of this project, we are relying on a software, on a GIS software, which is pretty important. It's going to be applied on most of the packages, for sure, for work package 1, work package 2, and work package 3, and it is at the basics of the development of work package 5, where there is a mapping component to show the outcomes of the project. So we are relying on QGIS, which is a free, most of you, I guess, know it. QGIS is a free software, is an open source software that is replacing, I would say, or it's becoming either as important as the other well-known ArcGIS or Esri platform, or other platforms that are kind of used that are available in the market. So we relied on QGIS mainly because we all know it from our side. It's pretty stable and well spread all over the world in multiple applications. And there is a good compatibility clearly with all the tools that we are developing. So for us, the GIS, and in particular the QGIS, is one of the most important tools that we are relying on. And so that's the reason why for these two days of trainings with Professor Biniam, who will take the lead on this. But before I let the floor to Biniam, let him introduce himself. Let me go to the last slide. Just remember some virtual training tips. So you mute your microphone when you want to speak, switch off your camera, and you just need to raise your hand. You just push the button, you raise your hand in any moment, and if you need clarification or whatever, you just raise your hand and we try to address the issue in real time. Other than that, the training schedule will be as last week. So we will have like 2 hours now until 1 p.m. Eastern Africa time. So we'll have a 2 hour session, then 1 hour break, and then another 2 hour sessions for today. And the same will apply tomorrow. So I would stop here. Binyam, I'll leave the floor to you. Let me know if you can. You should be also have the ability to share your screen, but let's double check.
Yeah.
So please.
Okay. Thank you, Paolo. Let me share and you can check it. Huh?
Yep.
Let me share my screen. Yeah, I just make it the whole screen. I think you can see it, right?
Yeah, we can see your screen.
Good. So let me introduce myself just with a video for introduction. So I'm Binyam, Dr. Binyam Tasfaw Ailu, and working. Any maybe someone has someone raise his hand.
Thank you, Benyam. I'm not the screen. The screen is not. I'm not seeing the screen which you share. Kindly share it again and let us follow. Thank you.
Okay.
Yeah. Try again. I can see it very well. So I don't know if it's an issue with the internet
Maybe
or
wait
just.
a few seconds. Yeah, it may come. Okay. So I'm Binyam Tasfaw Hailu, working basically I'm based in Addis Ababa University, School of Earth Sciences, Remote Sensing and Geoinformatics stream. I'm an associate professor of Remote Sensing and GIS. And in this work, I'm leading WP5. But for this training, I'm going to give you the QGIS training for you today and tomorrow. So that is the thing. So maybe let me open the slide that I have. Maybe they can you see now the slideshow?
I think it's now clear. Thank you.
Yeah, good. So can I start, Paolo?
Yes, please, Biniam. So I'll stand by, but again, I might not be all the time at the computer. Not because I don't need the QGIS training.
Yeah,
Just kidding. But yeah, in case of any, if you don't hear any response from me in case of issues, you just text me. I'll be here in 1 second. Okay, I'm still here. So please, over to you.
Yeah. Good. So today we will have a lecture session like about 40 minutes. Then we will directly go to the practical session. So I hope most of you are in front of a computer or your laptop so that we can easily follow each other. So the training focused in QGIS, but this lecture may give you some insights on open source GIS as a whole, and specifically to QGIS and geospatial data visualization and mapping. So today and tomorrow we will have this training. So to start with, most of you know about GIS, but here to describe a little bit or to define what it is. So it is a set of computer tools for collecting, storing, retrieving, at will, transforming and displaying spatial data for a particular set of purposes. So you might get different definition of GIS in the different sources, but all of them mention what they call spatial data or geospatial data or geographic data or georeferenced data. All of them are the same. So in this GIS, the main thing or the main component, the main part is geospatial data. So it uses geospatial data for Earth's information, any part of theirs, any feature of theirs. So it uses information about that feature, but with a combination of or with a system of computers, softwares, and even personnel. That means if you have all those hardware, software, data, if you don't know how to do it, if you don't know the procedure, what to do, that means not GIS. The GIS should cover all this. If you don't have the software, then that is not even GIS. So these 5 components should be there to define GIS or to define this system. So always there is an input and an output. So the input is geospatial data, and there is a process in the middle, and finally we will get some output. And we use that for decision making. So that's why you see at the bottom, GIS is fundamentally used to answer questions and make decisions. So that's about GIS. And it is like data, geographic data, physically, technology, hardware and software, and technical personnel. So this is a combination of this that makes it a system. That makes it a system. All the 3 components are strictly necessary to improve and develop a good GIS. Description of GIS. So of hardware, software, data, people, and methods. So they are interlinked. As you can see the arrows that it flows all the time. So it is a kind of a GIS or QGIS in your computer, that's not GIS. So GIS means a combination of all this. If you don't have data, that's not GIS. So it has to be there. So that's why we need this training. So to know how to do it, how to manipulate it in the system, and then we can make a full GIS. So, and to come here, as Paolo mentioned a little at the beginning, there are commercial software applications and open source software applications for GIS. So in this project, we use mainly open source GIS, so to make it stable. So this commercial ones, every time they need licenses, so always you have to buy it, and they will give you with a certain time period, then disconnected with a distributor, then after all the whole system stuck there. But using this open source software, that you can make it sustainable for the future as well. So now in this lecture session, I will give you a certain insight on open source software application. So it is an application, by definition, is software that GIS users can freely access and modify the source code for. So not only using, or not only to be a user, you can also have a chance to be a developer in open source GIS software application, specifically now in GIS as well. So you can be a developer because you can get the source code of the software. So open source projects typically are worked on by a community of volunteer programmers. So this QGIS as well, it's a part of this. So there is a community of volunteer programmers. They develop and they distribute the software in different versions. That's why you see always many versions of QGIS. For example, in my computer, we might see version 3.22, or now it's upgraded up to now 3.40. So in between, there is many changes. So always these programmers update or add some features and release to the users. So it is a project. Normally, project this GIS, QGIS, for example, it's a big project by itself. It's open source project. So they work together by the programmers. Okay? Or you can, users are programmers also users. So it can be also a programmer for QGIS community or project. So the main point of this open source software, it is many people understand that it is free. That means you can get it free of charge in terms of money. But it has 4 pointers of this open source software. So the following 4 kinds of freedom in order to call it free software. So it's not only related to money. So it is related to the freedom of or the freedom to run the program for any purpose. So you have a freedom to run the program. So you can only not to get free of charge, but you have a chance to run it, a program for any purpose. A freedom to study how the program works. So you don't have a chance to know how it works in case of commercial software. But here you have a chance to study how it works and adapt it to your needs. That means you have a chance to modify it. And the freedom to redistribute copies so that you can help your neighbor. That means you have redistribute copies. You can share it. So no need to have license, 5 licenses for 5 computers. This is individual, so this is for the company enterprise or something. There is no such kind of restriction. So you have a freedom to redistribute copies. And you have a freedom to improve the program and release your improvements to the public so that the whole community benefits. So if you have, or if you get some program and you can release it and share it, then the user test it, and then they will give you feedback and you can improve and you reshare it again. So you have a freedom to improve the program. So these 4 are the main pointers to make it, or to say it, open source rather than the money. So it is important to understand that the term free is about freedom and not about price. So that means you have a free license. It is customizable, interoperability, shareable, redistributable, portability, collaborative. All this is characteristics of this open source software. The benefits of this open source: no license fee. Resources are allocated to building application and enhance software. So not licensing multiple machines, so you can download and use it. Enables development of highly customized applications based on clients' need. And vibrant user community. That means whenever you request something, you will get a response related to that. And even they will update it and send you the latest version. So development priorities are driven by end user needs. So users are the one who drive the developers, and then get the best or the updated version of open source. Issues can be resolved in-house. So these are kind of benefits of open source. So when we come to open source GIS software, you have many options. You can use this link if there is an update on this open source GIS software. So the main one is QGIS. There is also ILWIS. It was developed by Netherlands in an institution. Saga GIS, Diva GIS, Geoda, GVSIG, and this white box geospatial Inc. and Grass GIS. These all are open source GIS software, but most of the time we use QGIS because it is almost it has almost all necessary things in GIS. Whatever you need, you can use GIS nowadays. So this QGIS is a free and open source GIS software licensed under GNU General Public License. So you can download it and use it in any computer. And this is an official project of Open Source Geospatial Foundation. So it is under the project. So every time there is a responsible project, a responsible people together and respond for you, for example. And it is a cross-platform GIS solution that is supporting a variety of operating systems like Linux, Mac, Windows, even Android. So it is a cross-platform GIS solution. But these commercial ones are like basically they need specific operating system in your computer. So QGIS is not only a desktop GIS, they also provide a spatial file browser, so a server application, a web application. So it has many advantages. So this is a site that you can get QGIS nowadays. So this is a project, also the QGIS project. So you can download the software, you can get the resources, and the community, those vibrant community, and the project itself. And if you have a chance even to donate, there is also a possibility to donate them because those are volunteers. So this is a site we will access it in our practical session after this lecture. So this is how it looks like. So this is a QGIS interface. This is a QGIS interface. Menu bar, add data, layer, list, map, view, status bar, toolbox. This is basically the main QGIS interface. We'll see that. And in detail, it looks like this. A browser, you have a browser, so you can easily access the data you want directly in the interface. So you can also use this open button, but if you use a browser, that will be easier and you can access your folders. And tools, these processing tools, it has many tools. So whatever you need, they even develop and integrate with the software, and it's called plugin. In a commercial software like ArcGIS, they call it extensions, but here it's called tools processing toolbox. So you can search. I mainly use this one, so I can search whatever I need, and the keyword, with the keyword you can find the tools. So you can easily access it through this toolbox, processing toolbox. Now let's see the GIS data models. So in any GIS software, we open or we use a real world information. So those information about the real world can be seen in this software or has to be seen in this software. And the data or the real world information should be either in a vector form or in a raster form. So we call them GIS data models, or representatives of real world, representatives of the real world. Let's say if you have a road, you represent with a line. If you have a lake, you represent in a polygon. If you have a kind of sample pointers, and you represent as we call it a vector. Let's say a town with in terms of scale, of course, in terms of scales. But these are GIS data models. So GIS data model enables a computer to represent real geographic element as geographic elements. So two representational models are dominant, raster and vector. The raster one is gridded based, even image, photographs, satellite image, all these are raster. Even a scanned map is a raster because it's gridded based. But those discrete lines, pointers, and polygons, they are called vector. So they are representative of real world. So you can see how real world can be represented in a vector and raster. In a vector, you can see it's a discrete line and polygon, but in case of raster, you see pixels, pixels. So this is an example of vector data model, and we call it vector data management. We will see in our practical session. So you can see polygons here and the pointers. So catchments in this basins, okay, in the Nile basin. Catchments at Bara subbasin, Baro Akobo Sobat subbasin, Blue Nile subbasin, Mainline subbasin, White Nile subbasin. You can see they are represented as polygons. And hydro stations, intro hydro stations, they are represented as pointers. So these are vector data models, like this. So we can also change the color and the likes on these data models in the vector data models in QGIS. So we can exercise this in the after a few hours or minutes. And raster data model is a kind of image. In this case, it is a digital elevation model that you can see in East Africa and Arabian. So you can see that. So the red color is continuous data. It's rather than this discrete line, points, and polygon. It has continuous data. So the red one shows the highest elevation, and the blue lowest elevation. So the range you can see, the gradient you can see it in the image, and it is in the form of pixel. Just to know, can you hear me? Are you following me?
Yes, we are following. Yeah.
Yes, Banya.
Okay. Yes, just to know. Okay. So this is how to access the data in QGIS for vector data, for raster data. Of course, you can see many other data types or data formats, a mesh, point cloud, delimited text, geo package. These are also kind of representation of real world, but mainly these two are the one, vector and raster. So this is how we can access in QGIS. Another point that you have to understand in GIS is coordinate reference system. So it's called CRS in QGIS, coordinate reference system. So there are mainly two coordinate systems. One is a geographic coordinate system. In easy way, it means you represent a certain feature in longitude and latitude. So the XY is in longitude and latitude. But in case of this projected coordinate system, we call it mainly UTM, Universal Transverse Mercator. It is a projected coordinate system from GCS. So the real longitude and latitude is a real representation as a globe or as a sphere, spherical. But for measurement purposes, for calculation purpose, let's say we mean measurement like calculating an area or calculating the length of a river or a road, you have to project it into transverse Mercator, into meter to get the length of a certain feature or an area of a feature. For calculation purpose, we use this projected coordinate system. Otherwise, you may not calculate properly if you use the GCS. So these are the main coordinate reference system. Most of the data that we have here, either of the two. So finally, we will see this map production in QGIS, how to create a map. So the cartographic application of this QGIS. Basically, you can do some analysis, even remote sensing, some detailed processes in QGIS. But finally, what you do is producing map to make it visualize or to make it available to the users. So it is for the sake of dissemination. So you use maps. We call them thematic maps. So you can also produce maps in QGIS. So it has also a cartographic application in addition to those sophisticated analysis. So we'll see this mapping as well tomorrow. So there are 3 modules that we categorize here for this training. So module 1 is downloading and installing the Quantum GIS and see the QGIS interface, and just looking the layers and the likes, saving the file, and that one. But in module 2, which is going to be this afternoon, so it is about loading spatial data and visualization in QGIS. So like looking the metadata of the spatial or the attribute data, coordinate reference system, and even the vector and raster data working with that. So that would be the module 2, which is the one which takes longer time, not only today, but also tomorrow morning. So that would be the one we will see in this training. And the module 3 is map production. So after working on the spatial data and visualization in QGIS, then we will try to produce maps actually, whatever. If you want to create a map of the hydro stations, the hydro station map, then a catchment map, river map, and the like. Only if you need for a map for a sub-basin, then we will try to see how to create maps in QGIS. So the geospatial data we will use in this training, one is a DSS data, this hydro station, meteo station, and ERA 5. This is new. It contains basically the grid of global data set precipitation. And HKHMS in this model, these catchments, and in HECRAS, there are rivers, cross sections, reservoir, and cities, and resim reservoirs in the model. So these are the geospatial data. In addition to this, since I already uploaded the raster data, which is a digital elevation model of the East Africa as a whole, then we will use that one for demonstrating raster data in QGIS. So that's all for the lecture session. And if you have any questions, please let me know, or you can text here. Any question?
Yes, Benjamin, there is one question from Bear.
Yes. Yeah. Okay.
Yeah, you can proceed.
Please proceed. Bear Alamayo.
Good morning, everyone.
Good morning.
My question is it, where do we get this raster and vector data? Is there any website? Thank you. This is my question.
Thank you, Bear. Actually, this data, this raster and vector data, you can find it in from different sources. Especially raster data like satellite image, the digital elevation model. You can find it from Earth Explorer USGS. So you can find them there. So for example, the one we will use for this training, I downloaded directly from USGS. So it is available for, it is global data. And even satellite images and the likes you can find there, you can download. And some organizations, they make available in their geo portal. For example, there is a RCMRD in Nairobi, based in Nairobi. So that is Regional Center for Mapping for Development. So you can find many resources in country basis, so national basis. So you can find it there. And you can search even in Google, like you need some data. And then if you type a keyword, then you will get some information where to get them. So these are free, what we call free data. But you can also produce data, this vector and raster data. For example, here in Ethiopia, this is a statistical agency, they produce data by themselves and distribute to the users. So you can produce data. And even here, by you have a scanned map, and from the scanned map, you can produce river data by yourself and then share it. So you can produce data, you can access through those organizations. Yeah, of course, they may have some privilege. So you maybe ask per request or free of charge. So it depends. So that is a source of data. Yeah, I hope it's clear.
Yes, Benjamin, there is another hand raised. Yeah, الجايلي بشير.
الجايلي بشير.
Hello?
Okay.
Hello? You hear me?
Hello. Yes.
Hello?
Yes, we can.
Do you hear me?
Yes.
Yeah, I am Jayli Bashir from Sudan. My question, this open source QGIS, after I loaded it, it is work in case of internet access or always it work?
So what happened on your software? What was happening?
It is well downloaded, but it is work when internet is access or in absence of internet, it will work.
Okay, I think this is standalone software, so it doesn't need internet access to work on the software. But if you want to upgrade, or if you want to access some free data like base maps, let's say base maps, there are Google satellites, there are Esri satellites behind in your data. You may need to see like Googlers, if you need to see it at the back, yes. Like an image. For that purpose, you have to have internet. Is that clear?
Okay, it is clear. Okay, I know.
Okay.
I have some mistake in connection, internet connection.
But after downloading and installing in your computer, basically it doesn't need internet.
Okay.
Any other question?
Yes, Benjamin, I think we can proceed since there is no hand raised. Yes.
Okay, good. So now let's go to the modules. So let's show you this manual. There is a manual that I shared to you. I hope all of you have this one. Can you see it? I think you have all this. So this is the link to download and install QGIS. So please go to this site if you haven't done it so far. So how many, I think, is there anyone who did not download and install QGIS in his laptop or in her laptop? Is there anyone who did not install it? Yeah, I think someone, Marnat, I don't know how I don't know how to pronounce it. Marnat, is that? So I think Diva.js website offers free shape files too. Yes, Diva.js provides shape files, but they are a bit coarser, and for detailed analysis, they are not as such good, and some of the data are outdated. So if you don't, if you want to see the regional in a regional scale, or if you want to see what it looks like, Diva.js website is good to get free shape files. But I'm sure this data, after you know much more about the actual data, these data sources are quite outdated, and sometimes they are not even correct. So of course you can get this free data that you can find in Diva.js. So how many of you did not download and install? So if not, I assume that all of you have installed and continue on QGIS, actual QGIS. So this is a place where to download. So skip it to download. Here you can see a long-term version for macOS. Because I'm in macOS, so that's why it keeps highlighted this one. But for you, it most likely, or for some of you who are not using macOS, or who are using this Windows, you'll see long-term version for Windows. So you can download that one and install it. So even in my case, QGIS is QGIS 3.22. So, but if I want to upgrade it, I can download this long term and install it. So this is a place where you can download. And if you need some information about the project, you can click overview. And if you want to go to the community, you can get here whatever you need. So you can be even involved in that. Resources like documentation, installation guide, books, roadmap all the time, and download, and even to donate. So this is a actual site for QGIS. Okay. So I hope all of you installed this. Let's see.
I did not install it. So this is the link.
Yeah, this is the link here. Shall I? Let me share you. Let me
share the
link.
links like that we can access it, because you see there is a lot of links, and sometimes it will be difficult to download right. The wrong one, not the right. Yeah.
In the chat box, huh? Yeah. So you can find it in the chat box. So let me give you some minutes to download and install it. Okay. Maybe 5 minutes. 5 to 10 minutes. Huh? Let's wait. In the meantime, if you have any other question, please.
Yes, I've opened the link, but should I download the green one, the long-term version for Windows?
Exactly. Yes,
3.4?
Yes, that one. The long-lasting one, stable.
Okay.
That is a stable version. Long-term version.
Now it's downloading, yeah.
Sometimes the difference between this latest version and long-term version is latest version is latest one, but some features may not be stable. So you will get some error message all the time when you try to open QGIS. So this long-term version is relatively stable.
Yeah.
Yeah.
Okay.
So here, even for mobile, like QField, actually, I have an experience on this QField. You can download for your mobile. And any project you work on a desktop computer, you can save it and share it to your mobile through a cable. And then you can access the data directly in QField. And sometimes this QField is very good for fieldwork, especially. So you have, if you have all the data in your mobile, and whenever you go to that place, you will see the actual information being there in the field. So that's the importance of this mobile and tablet. And Linux, for different type of Linux. And the one I don't know, for example, this BSD, I don't know about it. Yeah, and source code. So, and example data sets. Yeah, you can find here in this site. It might take to download. I hope it may take a few minutes, not even within these 5 to 10 minutes, depending on your computer performance. So, Okay. So let's see this overview of QGIS interface.
Bro, can we
Yes.
wait for a little bit so that we'll be in the same page, or how do you think? How do you see?
Okay, let's wait because you know we sent the link previously, but let's wait. It's okay.
Sorry.
It's okay.
Yeah,
It's okay. Let's
because
wait.
if we did not download, then we'll miss.
Yeah.
And
How
then
many minutes?
we'll keep asking, and we'll keep asking you, dragging you back, and then we'll not proceed there. So
Exactly.
let download so that we go together, the same speed. Thank you.
You are right. Let's wait. Okay, let's wait. How many minutes it says to download?
I think it's going well.
Okay, good.
Just remaining few.
Good. Let's wait.
Thank you. Yeah, Prof, I'm almost there. We can proceed. I'm just downloading. I'm just installing.
Okay, good. Thank you.
It is now installing.
So you can open the QGIS, all of you, and then you can see like this. So this is what we call the interface of QGIS. So it might be different from another commercial GIS software, but also almost the same. It has menu bar, it has layers, it has browsers, and even some links and some buttons, additional buttons. You may not see like mine in your computer because I was using different kind of plugins, and those plugins have different buttons. So you may not see like mine, but the basic ones like this new open, save, this button is the same. Zoom in, zoom out. It's common for all QGIS software. So you have to see this one in your computer, in your software. And it says untitled project. So it says untitled project. If it is new, then it is untitled project. Yeah. And these are the buttons to open the layers, and then here to see the layer lists, the layer lists, those vector layers, raster layer here. And you may see the menu bars here. This is a menu bar, actually the menus in a menu bar. So you can see project, edit, view, layer, setting, plugin, vector, raster. Until a raster, it's almost the same. But like database, web, mesh, HCM, GIS processing, you may not see it in your computer. Or in some computers, you might get it. In some computer, you may not, depending on what you were working on this software. Okay. So in my case, for example, if you see this HCM GIS, it is a plugin to see base maps, base maps like satellite images and the like. So you can download and install it, and you can see processing. I think it should be there, and window, and even this geoscience is a different. It's for my another project research purpose. So, but help it should be there. So you have this menus in a menu bar, and plugin, vector, raster. All these are there for you. So project. If you go to project, if you click on the project, you can see new from template, open, and the like. And to save, even to save the QGIS file, it's called a project. You have to save the project. So they call it projects. The file are QGIS files are projects. So that's why you see untitled project. Untitled project. So you can go to open, and then you can search in your folder, in GIS folder. There is a folder, or there is a data that's shared through Hydronova server. Have you got that? Have you got this data? Yes. Here in Hydronova, you see that? This Hydronova, this is a link. This is a link. How many of you got this training material?
I got it.
Okay. So
I think all the participants should got it because it is sent
exactly.
by in the email by Paulo.
Great. So let's see. Let's go to QGIS, and then you can see intro training dot QGIS. So QGZ file. You see that this one? You can open it. Open it. So you have this one. So you may get some error message depending on the version you are working on. So you can remove that, and then you can see this one. So all of you should see this interface, QGIS interface. And the name now, it says Intro Training QGIS. And you can see the layers are listed here. And the visualization part, this is a working area. So you can see. And using a pan, the hand button, you can move here and there. You can move it. You can move. And using this zoom in button, you can click on it, and then you can create a box, and you can zoom to a specific place like this. So you can zoom it to cartoon, let's say, so you can see. So if you want to zoom out, then you can click this zoom out button and then create a box. So with your mouse as well, without clicking this button, you can drag the scroll. You can scroll it and back and forth, back and forth. So that is zoom in and zoom out. So that changes the scale, by the way. That changes the scale. If you see at the bottom, you can see the scale is about 1 to 6 million. So whenever you change the zoom in, that means you are changing the scale. So zoom in and zoom out is related to scale, related to scale, related to scale. And if you want to go the last zoom, there is a button, zoom last. So zoom last, you can see zoom last. And the other one is zoom next, okay? So these are basic ones, pan, especially pan, we use it like this. Yeah. So you see the data here, spatial data. You can see in the form of a point, in a polygon, in a line, and an image with pixel. You see, Google Satellite is a free available base map, base satellite for the users. So that is in a pixel. That's a line, a polygon, and point. So if you want to see the catchments as a whole, you can right-click on HMS catchments, right-click on it. Immediately you can see zoom to layer. Immediately you can see zoom to layer. So you can zoom into the layer, you see? Then you can see the whole area. And if you want to zoom into the Era 5 precipitation, right-click on it, zoom to layer. So to specific extent of that layer, to that extent of the layer. And meteor station, zoom to layer. So it is different from the Era 5 precipitation. And hydro station, you can zoom in. And let's say reservoir RAS, you can zoom in to that place and you can see. So this is the extent. So these are the reservoirs are found within this extent. So you can zoom into that place. And this cross-section RAS, so zoom to this layer. To see the attribute for this Era 5 precipitation, right-click on it, then open attribute table. So that will takes you to the table, or that will takes you to the information related to precipitation, Era 5 precipitation for this area. So you can click open attribute table. The first thing that you have to see, or you see, is the feature, the number of features. So it says 59 features are found in this area. So Era 5 precipitation. So with different name, basin ID, area and square kilometer, and the like, you can see. So this is the information about Era 5 precipitation in this place. So this is attribute. So this attribute is linked to the spatial part. So if you select, let's say, this 5 of them or 6, then it's linked to the spatial part. And you can see yellow highlights, very small yellow highlights, but you can see them while you zoom in. So these yellows are the one which are selected ones. Yeah. So you can close it, you can close attribute. So this era 5, let's say for the catchment. If you want to see the attribute of the catchment, right click, open attribute. Then you can see the sub catchments or the catchments for each sub-basins. Sub-basin at Bara and the catchments here. For Baro Akobo Sobat, you can see, and for Blue Nile and White Nile. So about 59 features in total. 59 in total. So if you want to select, actually this is easy way of selecting or querying some information, which is selecting the row heading of, let's say, Atbara, only Atbara. Then you can see that Atbara sub-basin is the one which is yellow highlighted, okay? Yeah. So you can close it, okay? So you can see river Ras, so you can see the attribute of the line feature. Let's say open attribute table. So this is also 36 features here for the line. So river name with the river name and other information. I think some rivers are labeled as external, junction, and the likes. Okay, so you can get the information about the rivers here. So this is how to look at the attributes plus the spatial part. So this representation, this data model, this vector data model and raster data model, they are very good to visualize not only the spatial but also the information behind each files. And this file of type is called shapefile. So vector data can be represented as a shapefile. So it's called a shapefile. Shapefile. It's a file format. Let's say Word document, the one you write texts, it has .doc or docx file. So the same is true here. The shapefile is a vector file of type. And TIFF, JPG, these are IMG, these are image or raster data formats. We call them raster data formats. Raster data formats. So if you make some changes, like even zooming and zoom out, some kind of change, you can save it and you can open a new one. Let's say a new project. Or if you made some updates, you can save this as a different name. So let's do that, for example. So go to project, save as, and you will have GIS folder, and it says intro training, and you can type your name. Let's say Biniam, I just typed Biniam. So if I made some changes on it, so I can keep the original one and work on my project. So you can save it with a different name. So you see save as in a certain folder. The dialog box might be different in your case if you are using Windows. Okay, if you are using Windows, it's a normal way of saving in Windows. Like it will give you, I think, the same. The look in certain folder and then save as type at the bottom. Save as it's at the bottom. So you can save it. You can save. So now I have the name. I have a new QGIS project with a different name. And if you want to open a new one, then you can click new project and you'll see a blank screen like this. I hope it's clear. Any question until now? Questions?
Can you take me again through the how to save the file, because I was struggling with opening my RQ.
Okay, QGIS, now this empty. So that's what you can see when you open the software. So you can go to open project or go to project open. Either of the two. So let's say project open. Then search this GIS folder, the one you downloaded from the server, GIS folder. Have you got GIS folder? Then intro training.qgz. So this is the one I saved, you see, with the save as option, and this is the original one. Have you got it?
Yeah, I'm trying to, continue. I'm trying to.
Okay. Any other question? Maybe, okay.
Yeah, maybe, yeah.
Yeah, if some another question. So let's say, for example, if you want to make invisible of one of the layers, you can uncheck this box, can uncheck it. Or this is grouped one, so it is grouped under DSS. So you can uncheck the group itself to uncheck the whole part like this. So you can see only the Google satellite. So if you uncheck this one, you will not even see it. So if you want to check this HECRAS data, so you can see. So check, uncheck. Sorry, related to HECRAS. So these are main pointers. So you can zoom into the layer, and then you can zoom in, zoom out. So this is the information related to this HECRAS. Zoom to group. So this is you can zoom to the group. And if you want to make a Google satellite as a base map, then you can visualize like this. And you can zoom into the place, let's say somewhere in Aswan. So you can see this cross section lines, the cross section lines. Zoom to the group, this one. So if you can even uncheck one of the layers, let's say CTRAS, you can remove if you want to show maybe the dams, these reservoirs. So you can see these are reservoirs. You can check, uncheck, and the cross sections. You see, it is green because they are quite dense here. That's why you see a green line in the river. If you zoom into this place, these are very small lines. You see that? Very small lines, but not like along the river. It's a cross section. It's a cross section. So you can see the river is this one. The river is this one. So you can check the cross section. Yeah. Zoom to the group. Yeah. So this is to check and check, or to make it visualize, or to make it visible and invisible. Not removing, actually, not removing the actual data from the list. It's not removing, it's just unchecking, or no, to make it invisible. Invisible. Or to, let's say, for example, if you want to put this HMS at the bottom, so you can drag it to this place. So you can move it at the bottom. So catchment now at the bottom, and you can see the cross here. So you can see previously it was on top, so it's a polygon and a bit transparent, but now still transparent, but at the bottom of the cross data. So you can move it up. You can move it up like this. Like this. So to move it, just drag it. And to make it visualize, just check and check it. Check and check it. So now the catchment is on top, so we can drag it to this. Yeah, like this. So you can visualize. And even if you want to see the property of each layer, then you can right click on it and properties. So that's the metadata and especially information. You can see this is a metadata information in source. Any question? Please raise your hand for if you have any question, or mute your camera, your microphone. Okay, good. So this is a general information from the provider, coordinate reference system, and identification. So you can see the source, even the projection assigned coordinate system for the layer and the layer name. You can see. And if you want to make to change the symbol, we'll see later on. Labels, masks. There are quite many options here. Many options, but here basically you can see what its name, a path, where it is found in your computer, and what type of storage. You see is the shape file, so it's the shape file, and coordinate reference system is this one, EPSG 32636. So this is European way of coding of projections, and it is mainly the method is universal transverse Mercator. So this is the information about ERA5 precipitation. It's basic information. And for the catchment, it's the same, let's say properties. Then you can see this catchment, this kind of type of file, and the same coordinate system. Yeah. And Google satellite, you can see the information. Here is a Google satellite where is found, and some information about the extent, widths, and the likes. Yeah. And the coordinate system is pseudo Mercator. So this is a free available one, which is at the base. So to visualize this Google satellite, you have to be in internet connection, or you have to be in internet. Okay, so that's all. But for applying or visualizing this data, you don't need internet connection. And if you download it and open it in your computer, it is possible to visualize the rest of the data like this. But like Google satellite, it is basically in internet, so it needs internet connection. Yeah, and you can save it. And maybe any other question here in this interface related to interface?
Yeah, Prof, I think when you download the material from the sent by the trainer, I think it is in the zip file, those shape file, GIS training.
So this is
this one, yeah.
This one. So JS layers, you see, it's
yes,
zipped.
this one I've downloaded, but when I open open it from the ARC, it is not reading. Yes.
So this is a file. So it has intro training.
Yes.
QGIS. So that's what I opened. Even me.
This one, the white one, huh? This one.
Yes, this one.
Okay, let me try it quickly. I think.
Actually, you have to download the zipped file as a whole.
That's
Otherwise,
it. Yeah. That's what I'm asking. Yeah. Okay.
Yeah, you have to download. Let's say here you have to download it. Right click, download. Right click, download the whole layer. Or even it's better to download QGIS training material. Huh?
Yes, this is what I did, but
it has all download. Oh, even let me try it. It's downloaded in my case. It's downloading.
It's downloaded, but here it's not opening because I think I missed the zip file, something like that, maybe to download that one.
Yeah, and even you see now training material, I can open it and unarchived or unzip it, and then I can even unzip the JS layer, unzip it again, because it's zipped. Then I can see the JS folder here. And within JS folder, there is a QGIS file. You can even double click. By the way, if it is a project and it has layers, then you can double click and it directly takes you to QGIS software. So based on the software you installed, it's going to be opened like this. In my case, it's 3.28. But the data, the shape files are found here in this folder. Okay, so you might get some messages related to your activity actually in QGIS. You might get so many problems because you know the plugins, if they don't work properly, it will give you some message, and even if there is a new update, then it will give you some message to update it or to upgrade it. So if you want to keep unavailable layers, you can keep it, you see. So this is a QGIS file for my case. You can check all the files. I just directly opened from zoom to group, so you can see that. So now this is from the server. I downloaded directly from the server just now and opened it in QGIS. Okay. So Google satellite comes, you see. Maybe there is a problem in this HMS reach, so you can remove because it's not available. If it is not available in the folder, then it will give you some kind of this message buttons, exclamation, stop it, or no data. So if it is necessary, you have to repair it. If it is not, you have to remove it from the layer list like this. And if it is necessary, you have to fix it, or you have to ask the person to give you the data, and have it here. So this is directly from the server. So it should be like this for you. How about the rest? How is it? How's it? Okay, there is one question from Bear Ramayo. This how all the layers in the same UTM zone? Okay, good question. I think very good question. Here, when we see the properties, you may see this is WJ84 UTM zone 36 north. Let's see this one, reservoir. Here, they are the same. That's what he asks. I think that's it. So how? Because this zone is found somewhere here, maybe some part here, zone 37. So a bit this part, central part of Ethiopia, as far as I know, this is zone 37, and most of the part is zone 36, and this part is zone 35. Maybe I'm not sure, but you know the reason is Paulo may explain very well in this question, but as a GIS person, the reason is we have to put, even if they are in a different zones, we have to put the same coordinate system to overlay in one, or to visualize in one layer, or in one extent. Of course, the pointers, when you collect them, the point, for example, pointers, when you collect them, they have to be in the right zone. But when you try to visualize, it should be in the same zone. Even when we collect data, we always recommend to collect data in GCS WJS84, in GCS in lat long, and projected to the right projection system, to zone 36, to zone 37, and the likes. But for visualization purpose, if we change these pointers, because they are all together, you can find them in the same in one file. Let's say this precipitation is one file, but the pointers are in different zones. But to make it visualize, we have to make it the same coordinate system. Otherwise, we cannot get them at, as a layer here. That might be the reason. I hope this explained well. Maybe Paulo explain later on. This is a very good question. Good. Any other question? Have you managed? I don't know. Have you managed to download and open the right QGIS file?
Yes, I have managed, but it is giving me some error, need repairs, as you explained. So now trying to do the repair.
Okay. So I have two files. Let me close one of those because I was trying to show. So whenever you close it, it might request you to, do you want to save the current project? If you don't want to, just don't save it. Because I have another one, it's already opened. So I just click don't save it. So maybe here you can see at the bottom, it's EPSG code D32636. So that's a common, the common coordinate system for all layers here in this project. So just to visualize, you can see it here. You see? Yeah. So it covers this part. Zone 36 is this one, of course, but for the sake of like visualizing in one project, in one QGIS project, we have to make a similar projection system. Otherwise, very tough to visualize. Some of the data will be, or we have to put them in a different layer. So here, intro meteo stations, it will not be one if we change the projections of other points here. Yeah. And if we don't make UTM and keep this GCS, we don't have a possibility to do some calculation. So that there must be some kind of coordinate system which is similar for different places, close to each other at least. At least it should be close to each other. Otherwise, if you make UTM zones 33, it will not. It will be here. So it will. It doesn't give sense for all the layers. Any other question? I'm giving you actually some time to exercise on it, to open and close the file, the project, visualize it, zoom in, zoom out, and to change the layers, properties, to see the attributes. Try to see the attributes, try to zoom into the layer and move it up and down and check, make it visible, invisible in the layer. So try to exercise those. And if you have some questions, then raise your hand and ask me. So I'm just giving you time to work on it. Muna, okay.
Yes, Benjamin, is there any exercise to let them know how to specify those projection from the scratch, I mean?
Yes, we can prepare and share it, but you know, it needs time to even give a lecture for projection system and how to specify a coordinate system for a point or a line, then project it to another projection system. That really needs time for that. So this is a basic lesson or basic training. Maybe those may need some advanced training related to this. So a point can, when you collect it, it should be with a certain projection system. And then to convert that, there is also a tool in QGIS, how to project it, and then have some kind of coordinate system. So it takes time. That's the reason why I'm just answering the question to the person who raised.
Mm.
But
I think it would be worth if just not practicing, you can just mention it theoretically how they from the scratch they can build the file, vector file, and then they can know how to use these projections. Those issues.
Okay, in QGIS, I can demonstrate that one. Okay, let's say, for example, here we are here in this QGIS environment. Then if you want to project it, there is a tool called project tool. So you can go to processing toolbox, let's say project. So project. So you have a right to reproject a layer. You see that? And if you want to define projection for a shapefile, you can define shapefile projection. So one data might not have a projection at all. Then it says unknown. Mostly when you get a shapefile from a certain source, you may get a projection with unknown projection system. At that time, you have to define the projection system. So you can define the shapefile projection, you can assign projection, and you can reproject of a projection for a certain layer. So let's say if you want to reproject, you can type here in processing toolbox. I think, I don't know, most of you or all of you should get this processing toolbox from here. Okay, in the menu bar, you can see processing toolbox, then project. You can type project and then reproject layer. Then this is a tool to reproject. It says, you see this algorithm reprojects a vector layer. It creates a new layer with the same feature as the input one, but the geometries reprojected to a new coordinate reference system. Attributes are not modified by this algorithm. So you will get the same attribute, but the only thing that you will get is a different projection. So let's say this is intro meteor station. Then if you want to project to a new projection system, let's say in this kind of GCS WGS 84, I have a list of those, but in your case, you may not see it. Huh? In your case, you may not see it because you haven't used it previously. So I used to change different projection in my case, in my researches, okay, in my work. But you can find it here in the next to this target CRS button. Select CRS, coordinate reference system, and then you can filter or you can search it here at the bottom. You can search it here. There are quite many coordinate reference systems. Basically, there are geographic coordinate systems and projected coordinate systems, okay? Projected coordinate system and geographic coordinate projected. Geographic one is simply with lat long, okay? Lat long. In degree, minute, second, or in degree, minute, decimal, or in degree decimal. So lat long, longitude and latitude, okay? That is a geographic coordinate system. In this case, the system considers theirs as a sphere. But in this case, in the projected coordinate system, this system considers theirs as a flat, two-dimensional way of presenting. Huh? So this is the one we use for measurements, projected coordinate system. So in the geographic coordinate system, you can see many reference systems developed by these geodesists. Geodesy, the science behind this called geodesy. So they develop these algorithms. You see, quite many. But the common one that we use in most cases is WGS84. So even WGS84, it has many, they upgrade it, or they may develop in different ways for different purposes. But the basic one is the one we use commonly in many cases. Even GPS uses this WGS84, this EPSG code with 4326. So we use this one in a geographic coordinate system. You can see even detailed information about this WGS84. So the property is geographic, uses latitude and longitudes for coordinates. So dynamic rely on a datum which is not plate fixed. Method lat long, which is geodetical as well. This is the one. So this is the basic one in terms of longitude and latitude. So we can convert to that one. We can convert that to that one. So you can choose here. And the other one is in the projected coordinate system. It has also many type of coordinate system in the projected one. So developed by many geodesists in different countries for different location, okay? So you can see WGS84 with the common one is this WGS84 or the Mercator, WGS84, UTM is a common one. So you can get it at the bottom. So it is quite many, you see? So this is depending on the datum or the local datum, the local datum. The local datum, for example, in our case is Adindan. It's called Adindan. So Adindan UTM zones 37, 36 are quite known, okay? So where is it? This WGS WGS84 UTM zone, this one, common one. So if you see this 33 north is somewhere here. So 36 is here. Yeah, and 37, for example, is this one. In my country, for example, in Ethiopia. And sub part is this is south. So the 36 north. So in this work, in this project, we use this one, the UTM zone 36 north. So you can convert it. So I will not convert this data to this coordinate system, but there is a possibility. This is a way how to reproject it, how to project it, and even how to define it, okay? So let's say you can define a projection. So this is a intro meteor station, this one. So you can define, if it is unknown, actually it is already defined, so no need to define it, okay? No need to define. So, rather, you reproject the layer. But for unknown coordinate system, you can define it. So this is how to give a projection system for a layer. I hope in short, it is clear. Muna, I hope this is okay.
Yeah, it's clear for me. Thank you.
You're welcome. So another question is, can we export the file today, or that will be for tomorrow? Of course, it is possible. I just expect the question like, is it possible to export it? There is a possibility to export, of course. But in my lesson, I can show you now, okay, as an example, to export it, because it's better to answer your question now. So let's say if you want to export ERA 5 precipitation, right click on it and export save feature as. So you can export it. You can export a file. And you have to identify a location to save. And you have to identify the file name. And you have to identify, or you have to choose a format. So what kind of format you want to choose to export it, okay? So let's say Esri shapefile. If that is the one you need, you have to choose Esri shapefile. But you can also export in different ways, in different type of data for vector, especially here, okay? So some softwares, open source, whatever, they may need a specific type of vector layer, specific GeoJSON, for example. It is okay for another software, but not for here. And this KML, let's say this keyhole markup language, it's a file of type for Google Earth. So if I want to export this ERA 5 precipitation to visualize it in Google Earth, I can export it to XML. But if I want to export it to another, or to distribute to another person, or to save it another place, with the same format, you can use Esri shapefile. So let's, for example, to make it really visualize, you can export this to KML and then save it to a folder, let's say to our GIS folder. Here we can give a name, which is ERA 5 PPT, precipitation. So I can save it like this and then save it. So in that folder, I just save it with the name KML. So ERA 5 PPT. So that's the layer name. That is a file of the place, including the path, the path where I saved it. So that you can say, okay, with the same coordinate system or with a different coordinate system, let's say 4326 with a GCS. I can save it like this. So, okay. And if you want to add it here as a layer, possible. Okay, add layers. So it will add it here, okay, as a layer. But no need to add it here. You can remove it. Just to remove this unwanted layer, right click, remove the layer, and then okay. So this is how you can remove it, the unnecessary layer in your layer list. And this one is the one I saved in GIS folder, which is KML. Then I can open it directly. If you have Google Earth Pro or Google Earth, it will be opened in Google Earth. So now I can export it. There is a possibility to export a layer. There is a possibility to export a layer. You see, these are the pointers in Google Earth Pro. So you can visualize it and view tilt, then you can visualize. So these are the layers, okay? The pointers, the files. Here, this is a layer. So you can uncheck, check it. This is now in Google Earth Pro. I just exported to KML file, okay? KML file. I hope that is clear, Marnat. There, small parts of the Blue Nile fall within UTM My question is, did we miss any parts of the GIS layer analysis? I think this question should be goes to Paulo, because his team developed or produced this data. Let's keep this data, these questions, especially I answer this one. So let's keep this question, this one and this one, and we will raise it to Paulo. Hope he will answer this. Yeah. Good. I hope let's stop here and continue after an hour. What do you think, Muna? Muna?
Yes, it is the time according to schedule. It is a time for break for 1 hour. And then at 2 o'clock, we will proceed.
Yes, let me copy, just a second. Let me copy these questions to before we disconnect.
Okay.
Yeah. Yeah. Yes, let me keep these questions. Because it's related to the production of the data. Yeah. Good. And now we can disconnect and or let's keep it like this, huh?
Yeah, it's upon to
me,
the participant if they want
it's
to just keep. Okay, otherwise you can log out and log in again.
Log in again. Yes.
Yeah.
Okay.
Yeah. Sorry, once just small reminder before you go out. I just posted a link to sign for today's participation. You can also do it later. Please don't forget to fill out your details on the form. I will reshare the link as well. Thank you. Enjoy your lunch.
I think this one you mean, huh? This one.
Yeah.
Yeah. Okay. See you later.